Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA, which looks at the cement industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA, and your host on the Clinker Factor. Today, I'm talking to Josh Vernon, who recently became CEO at Carbon Re. So Josh, welcome. Can we kick it off by asking you to just introduce yourself and how you came to your current role?
Absolutely, and thank you very much for having me in. So I came to my current role. Previous to this, I started a company in a completely different field. So the world of cement is still relatively new and exciting for me, although I hope it remains exciting for many years to come. My previous role was starting an organization in the finance and HR space. So I did that just after leaving university, where I did a mechatronic engineering degree. So back to my roots in systems, more so at Carbon Re than previously. So I did that, ran that business for about 8 years. It was then acquired and then started to dive into what I could do around the climate space to make a meaningful impact in the short term, and came across the team at Carbon Re.
Yeah, so it's good to have somebody who has a fresh perspective on things on the podcast. I think in terms of the application of AI to the cement industry, I think it's well established, at least in two particular areas, one being process control, which we'll primarily talk about today, and the other being in maintenance, so prescriptive maintenance. So AI in the cement industry, we're not really talking about large language models and some of the things that have been most fashionable recently. This is the application of machine learning to industrial applications. I think most of our listeners would be somewhat familiar with this. So what I thought we could focus on today, Josh, is really some practical issues around the application of AI. So perhaps we could start by looking at, in order to deploy AI effectively, what level of system integration is needed? What are the things that you need from the client team to form that solid foundation for what you're helping them with?
Yeah, it's a very valid question. And maybe just to comment on what you said before around it is the type of artificial intelligence that we're talking about here is fundamentally different to the chat GPTs of the world, which have done an amazing job in creating hype or excitement around this space. But it is a very different type of data that we're dealing with here. And I think that leads into the challenges from an implementation perspective more than anything. As a side comment, I do think the type of or the application of machine learning that we're talking about has the potential to perhaps have a bigger impact than other types of AI. So I think it's exciting that we can apply it to cement. But on your question around the practical implementations, and I believe you ran a cement plant for many years, so you would be well aware of this, but the data that is coming out of a cement plant is very, very different to the type of data that a large language model is being trained on. And that foundation of a messier, more complex environment sort of sets the stage for the differences and the practical limitations or challenges in implementing AI. So I can run through really what we look for in a plant in order to start with them. But I think that whole piece around the messier data is the foundation that we work off to work out how we have to get around that.
Yeah, so I think, messy data is something that cement companies have, recognized and struggled with. But I think when we're trying to use it for AI models, it's probably a different kind of level of intensity and a different degree of automation, much less human interaction. So the need for better data must be, more serious.
Yes, correct. So I think when we think about it, so you have to have the right sensors in the right areas of the plants, and we can be relatively flexible when we're thinking about how we need to model the environment. But in order to model the environment, you need a signal from the environment. You then need some way of collating that information. Most people today have a cloud historian, and then you need a method to be able to share that data with third parties. So for us, that's over a connection, similar to an API connection, an MQTT connection. So right sensors giving you the signal, collating that information, then sharing it. And then there's a whole bunch of work on our side that goes into cleaning and regularizing the data so that it is usable by machine learning models. So as an example, one of the products we create is an O2 recommender or an airflow recommender. And the signal we're getting on O2, there's a cleaning cycle, let's say every 8 or 12 or 15 minutes, however often that is. And that cleaning cycle, if you're not picking it up and removing it from the data, fundamentally changes what you're looking at. So the industry has done an amazing thing in investing in all of this data and this information, but so the industry has done an amazing thing. AI companies coming in off the bat trying to look at this data with fresh eyes will really struggle. So it really is about bringing in the context and the understanding of the cement world together with that AI, where the sort of rubber hits the road.
Yeah, and I think you were talking when we discussed this earlier about things such as the positioning of sensors in silos making a difference to the quality of the data that was collected.
Yes, absolutely. And it has amazed me. I don't know if this is just being a relative newbie to the industry, but the nuance in each plant's environment has amazed me. So I think that's another challenge, that if you're an outside AI provider coming in and trying to understand that, is different to the approach we've taken of trying to bring in cement expertise, which can help us understand that.
I know you've implemented systems in plants that have been well prepared and other plants that have been less well prepared. How would you characterize the difference between those two groups?
I think it comes down to the people more than anything. We've been fortunate enough to work with some absolutely fantastic plants. An example might be there's a Heidelberg plant that we work with in the Czech Republic called Mokra. They're running at about 86% TSR, a really advanced plant on what they want to be doing with their technology. And the people there are sensational, sensational with regard to their understanding of the process, their understanding of the data, and what they want to do with digitalization. And then there's some other plants where it is perhaps a more traditional and a bit of a messier environment. And I think it is the people and the view of investment into digitalization, which is at the crux of that.
Is there a sort of a minimum amount of investment that you need before you start seeing the bigger returns? In other words, if you just invest in sort of partial systems, you don't really get the return that you get from a really integrated system.
It's an interesting question. I think what we're seeing in the industry today is that there has been years of investment that are layering on top of each other. And up until recently, it has been very hard to prove any ROI or any return on investment in digitalization. So often we hear people talking about digitalization in cement, but not having the dollars and cents savings to accompany it. So I think AI is probably one of the first technologies on top of an APC where you can say, we can now take this data, we can optimize the process and increase efficiencies to whatever that end objective is, to increase the TSR or reduce SHC. So I don't know that there's a minimum level of investment, but it is clear to me that the final piece that we're at now, it's definitely not final, more will come, is one of the first times in the industry we can demonstrably prove a return on investment from a digitalization project.
And I guess in implementing these projects, it's partly a data project, but partly it's requiring process knowledge. And I suppose that that's something that you have, but it's something also that the client needs to provide. Is that right?
That's absolutely correct. Again, on the data point, it requires the process knowledge, and we've invested a huge amount in that, because without the process knowledge, when you look at this data, it's almost gibberish. So you really need the expertise and to work in partnership with customers, but you need the process engineering expertise on the customer side paired with our internal cement and process engineering teams to work through that data and make sense of it. You're absolutely right. A lot of it relies on the people.
Does your system require the data be available on the cloud that you can, access remotely, or
It does.
it does? Yeah. And do you find that raises some IT security issues that go beyond what the cement companies are already concerned about?
It has been a minimal concern. It hasn't popped up in many of our customers to date. I think the reason is because where we operate in the cement ecosystem, or the pyroprocess ecosystem for now, is on top of an APC. So we operate the product in closed loop control with either the soft sensors or set point recommendations. But the information that we are communicating back to the plants to optimize the BZT, the burning zone temperature, or the O2, or whatever it might be within within the plant, we're plugging that into the APC. And there's a lot of trust in the industry from a security perspective in those APC systems. So layering on top hasn't represented a challenge.
Right. If you're talking to a plant manager, and so the plant manager is thinking, well, I wonder if my plant can benefit from implementing AI to assist with process control. So how should he think about this? How can he tell whether or not his plant is ready, could have a return from investment?
I think the bottom line is that any plant will benefit from AI. It's a question of timing and when that plant might be ready to make that investment. And we're finding more and more plants are at that point. The areas that AI operates best in are complex, adaptive environments that make it difficult for a human to make the correct choices in real time. And if you think about that description, a cement plant is almost exactly that, or the pyro process in particular. On a given day, you have very different alternate fuels coming in, very different raw meal. The amount of change going on is immense. And the fact that traditionally we have relied on humans to understand all of that complexity and optimize the process in real time, it seems like a challenging task for any human to do. So, and it also seems like it lends itself, and what we can see from the results is it lends itself really well to a machine learning type approach or an AI type approach. So I think anyone will benefit. I guess it's a question of when a plant is ready to make that investment.
So in simple terms, if you've got an APC system already, you've kind of already got something helping the operator to do a good job on control. How is AI able to improve on that? What is the AI doing that enables an improvement on APC?
So I think the easiest way to think about it might be that an APC is automating control or the control room operator, and AI is automating or supporting the process engineer. So optimizing on top of it. So APCs are fantastic at providing that base level of control, but what we're trying to do is fill in the information that APC is missing in order to run the plant more effectively. So a simple example that most of the audience might be familiar with is the concept of soft sensors. So with many of our customers today, we provide a soft sensor for quality, so Freelime or C3S. In a traditional plant, you're collecting that and measuring it and feeding it back into the APC or manually. Let's call it every 1 to 4 hours. With AI, you can look at the historical data and the current data, and you can assess in real time or make a prediction of what that Freelime or C3S content is, and then automatically or in real time and without human intervention, feed that back into the APC. So you can imagine if the signal the APC is getting is more accurate and in a more timely manner of what that quality content is, the variation reduces significantly. So that customer that I mentioned, the Heidelberg customer, Mokra, the variation in their C3S from using this product has reduced 33%. And it's a really meaningful adjustment just from implementing a software sector.
And I guess that's allowed them to optimize their clinker factor in the cement and have related cost savings and carbon savings as a result of that.
Exactly. So you can think about the downstream effects of that. If you have reduced variation in clinker, then you can optimize the clinker factor far better.
Is there some advice you would if for companies that haven't started to implement AI, is there some advice that you would give them in terms of what to do to prepare for it?
Outside of speaking to us, but I know this isn't a sales podcast, so I will leave that for the time being. I think making sure your data is in good order and you have invested in that, which the industry has done a phenomenal job on as a whole, making sure that that is in good working order so that when the time comes, you're ready to actually get a return on investment from the data investment, and the AI would be a fantastic first step.
Yeah, I think in my experience, just investing in the data is probably not enough. The question.
What else would you add to that if it's not just the data in your mind?
Yeah, no, so what I was going to say is in some cases you have systems that produce tremendous amount of data, but the management reports don't use that information. They're separate information in an Excel sheet, for example, and so on. And so when you get this system disconnect, you very often get poor quality data in the TIS system. So I think one of the things that I would recommend as a first step to trying to make better use of AI and to become more fully integrated is to make sure that your management reports are directly using the TIS data, because then you'll pick up when the data is not right and you'll fix it, as opposed to just sort of ignoring it. So I think that feedback loop in the usage of data is what helps management teams to make sure that data is accurate. And it's not always done even when the investment has been made in systems to do it.
An extremely fair point. It's a culture of collecting and utilizing data intelligently in the plant, even at a very simple level.
So, is there a potential, particularly in smaller companies or smaller companies that have relatively few plants, to share data that might allow models to be built more effectively? Obviously, with large groups, they have a lot of plants that they can share data with. But is that something that helps, or is every plant a sort of standalone system?
A bit of both. Every plant is a standalone and very unique environment, and I think that's what most artificial intelligence companies coming into the cement space get wrong. It is not a traditional software business where you can roll out, even SAP, for example, the amount of customization that is involved in that is intense, but it is still a software product that you can sell to almost anyone on Earth. A cement plant, to model it, I think you have to be more conscious of the nuances, but there are definitely learnings in the process of developing AI that can make it more efficient the larger the number of plants are that you're going to. So whether that's a better understanding of how cleaning cycles are done on particular sensors or whatever it might be that you can share across the group, that definitely exists. And I think as an industry coming together to get the benefit out of the investment in IoT over the last 20 years, we will be better off sharing that and keeping that open source to the extent it can be so that everybody can benefit from it.
Yeah, so you're able to recognize patterns that are characteristic of specific problems, and having seen them before, you say, "Oh, that's probably this." That's what you're saying, right?
Exactly correct. There is a world where it is believable that you can build a model of a plant environment or a pyro process, even if you're just taking it to that level, that exists and you could roll out and it could learn the behaviors of every plant. I don't think we're there yet, and we are a stage earlier of going in and understanding in a plant by plant fashion how to model that and get the most out of it.
So you mentioned several times building on the APC model or the APC system that plants have in place, and I think you have a partnership in place with FL Schmidt. Can you explain a little bit how that works and why FL Schmidt thought it was worthwhile to work with Carbon Re as opposed to do it themselves?
Absolutely. So we have a fantastic collaboration with FL Schmidt. We will also be announcing over the coming weeks another collaboration with another large OEM provider like FL Schmidt, and we're extremely grateful to work with them because of their understanding of the pain points in the industry. The question of why they aren't doing it themselves is a fantastic question, and we can ask them. But to relay what I've heard from them, I think the strong signal that they're getting from customers is that on top of the APC, there is a bunch of work to be done around optimization. So you have this control platform in place today. You have an aging workforce with the skill set, if we're being honest, being lost in some senses on proper control and process engineering in some cases. And you have a need to recognize the rapidly changing environment of the plant. So we're increasing TSR faster than we ever have before. The raw meals all different, all of this complexity, and the control is fine, but the optimization of it is a challenge. And AI is really the tool to do that. I think we are in a fortunate position as a tech company spun out of Cambridge and UCL that we have access to some really world-class machine learning engineers and AI folks, as well as the cement side. And we bring that together in a Venn diagram to hopefully create impact for customers. But I think it's that mix that allows us to be hopefully an impactful partner for the likes of FL Schmidt, yes, rather than building that in-house.
And I think you're also looking at the potential for applying your technology and your approach to other industries. Is that right?
Yes, we are. So we're 100% cement focused at the moment, and we're being pulled now by customers into the adjacent areas, so whether it's grinding or elsewhere in the plant ecosystem. Our priority is to focus on customer demand. So we really love, and we say this genuinely, but love working with our customers who tell us which areas of the plant need the most optimization support. So wherever that is directed is likely the direction we'll move in, but it isn't a meaningful jump to think that the same way we can model a combustion process in cement, we could go to other industries, steel, glass, paper and pulp, etc.
So you're mentioning TSR, and obviously alternative fuels have always had some complexity, if you like, in terms of the challenges of running the plant efficiently. So I'm sure that AI has something to offer there. But so that's one specific issue. Are there others? I think earlier you were mentioning C3S, so there's a quality optimization piece that you're looking at. Are there other areas that you'd like to highlight?
The quality and the increasing TSR are the two main areas we're working in the moment. And I think they're also two critical areas when we think about the pyro process. We are starting to work with customers now on grinding and other areas of the plant, but those are the two things we focus on in pyro right now.
Right. Okay. In Europe in particular, we hear a lot about decarbonization. And if I talk to CEOs of cement companies or indeed other building material companies in Europe, they're spending a huge amount of their time on decarbonization. And we see that CCUS projects are really sucking up a lot of CapEx. I'm wondering what you're seeing in terms of the amount of investment that's going into decarbonization in the cement sector and where that money is being spent.
Yes, it's fascinating. So my background is in, I guess, more traditional software startups, and coming into the cement space. One part of your brain can think that it is a quieter part of the world, which has been done the same way for 2000 years, but you very quickly get smacked out of that and recognize just how rapidly everything is changing. And I think, or I am sure now investor landscape is pushing that in a meaningful way. So the investors that we speak to from a company perspective are extremely excited to tackle one of the largest emitters as an industry. There are, I guess, a couple of different ways investors are thinking about it. There's the very long-term bets on new cementitious materials or new ways of recreating the pyro process or removing it altogether. There's also carbon capture, as you mentioned, CCUS. I think there is an equal amount of excitement for applications of technology for the existing industry, because a lot of that is either extremely long-term or changing the industry as it is. And if we want to have an impact by 2030, which is really critical for reducing our long-term emissions or the radiative effect of those emissions, we need to do something today. And I think the application of AI is in a really unique spot to do that. So from an investment perspective, we're starting to see that narrative pick up. It's a two-way street where, as much as technology companies can be spun up to try and work on these problems, the cement industry, and they are doing an amazing job of this. And we're thankful to all our customers need to, I guess, come to the table and saying, yep, we want to solve this, which it seems like the industry is moving fast towards.
Yeah, I think that's a very important point, actually, Josh. Well, first of all, the cement industry would rather do anything except CCUS or CCS in terms of decarbonization, just because CCS is so expensive and so capital intensive. And secondly, CCS projects are typically taking 7 years or thereabouts from announcement to planned commissioning dates. And in addition to that, there appear to be a number of regulatory bottlenecks and supply chain bottlenecks that mean that at least some of those projects are likely to be later. So if you were to start a CCS project today, you would definitely not have an impact before 2030. Whereas projects to improve TSR can have an impact very quickly. And of course, you can install an AI system very quickly as well. So I think that timing is very important.
Yes, the timing. And each year there's over a gigaton of emissions coming from the industry. So each year of that planning or the creation of CCUS, we're falling further and further behind. More than that, though, I think One of the most unique things about AI when we're discussing with our customers in cement is that there's zero capital investment cost and it can be implemented immediately and it saves money. So we
Yeah.
will never go to a customer saying we are only doing this for the carbon emissions reduction. That is a benefit of what we're doing, but we're doing it to improve the efficiencies and save dollars. So it's a pure profit and loss conversation that we're having. It happens to be that what we're doing is increasing TSR or reducing SHC. So again, that Heidelberg customer, we've reduced SHC by 2.2% in the first month or two working with them. Which is a meaningful bottom line impact for the majority of plants out there.
Yeah, no, that's a very significant saving for any cement plant.
Yes.
So, Josh, it's been a pleasure talking to you today. Coming back to the point you made at the beginning, your enthusiasm for the cement industry may never fade. You may never leave and work in another industry again. But my pleasure speaking to you, and I wish you all the best.
I hope that's the case. Thank you very much. It was a pleasure being here today. Have a fantastic day.
Thanks for listening to the Clinker Factor podcast today. If you've enjoyed it, do subscribe and please recommend us to friends and colleagues and anyone else who you think would be interested in what's happening in the cement and concrete industry around the world. WCA is a not-for-profit company. Please visit our website to see the services that we offer